All right, next what we're going to talk about is linear equations and linear inequalities. We have to talk about the inequality part. So you might remember from first grade or kindergarten when you were talking about comparing two numbers, you would compare them using alligators or hippos or something else where the symbol eats the bigger number. So that's what we're going to be using here, and it's something we've talked about for a long time. Throughout all of your math history, you compare things. That's part of human nature. Humans compare different things. Um, so when we're doing that, that's going to be really useful when we talk about real world applications. Uh, if we're talking about pay scales, we may have a situation where we're comparing a pay scale with a salary at a 40-hour a week versus I get paid hourly for certain numbers a week. So kind of going back and forth to figure out what's a better deal, what's going to get me more money, what's going to be better for me. And then this is really big for interval notation. So just making sure that we practice that so it's always there for us. So one thing that we need to talk about is and versus or in math. In math, when we say and, it means everything has to be true. So if we were to say Mr. Schellenberg is tall and is the principal, that would be something that has to be true. If we were to say an administrator at Mount Lake Terrace is tall and is a principal or an assistant principal, then that doesn't work because Dr. Castilleja is not as tall as Mr. Schellenberg. Mr. Falk's not as tall as Mr. Schellenberg. So we need to make sure that when we say and, everything has to be true. If we say or would imply that it could be anything, or it could be both of them. So or means any or all are true. So if we were to say use an or statement, we could say that at Mount Lake Terrace High School, a math teacher is Mr. Ossink, or is Miss Lee Henning, or is so all of those things could be true, and all of those things could possibly all be true. So when we're talking about or, anything can be true. If we talk about and, everything has to be true. And when we're solving inequalities, everything's the same except when we say subtract, things like subtract from both sides. There might be 3 parts, so we might really mean from all parts. And if we multiply, wow, apparently I cannot write neatly. If we multiply or divide by a negative, all inequalities flip. So if it opens to the left, it's going to open to the right. Greater thans become less thans. Less than or equal to's become greater than or equal to's. They just have to make sure that we flip them back and forth. So when we're talking about that, the first thing we're going to do on these is undo our addition or subtraction. So on this problem here, I need to get rid of this minus 3 But there's not two sides. Now I have to do it to all three parts. So I'm going to add 3 in the middle. I'm going to add 3 on the left. And I'm going to add 3 on the right. So once we no, it's not cooperating. So I'm going to get 4 is less than or equal to quantity 2x plus 4 over 4 is less than or equal to 7. The next thing we have to do is going to be to undo multiplication and division. So I've got that divide by 4 there, so I need to undo divide by 4 by multiplying all parts by 4. And that's going to simplify down to 16 is less than or equal to 2x plus 4 is less than or equal to 28. Step 3 is leave. No, that's not what step 3 is. Step 3 is undo exponents. We don't have any in linear problems, but they might show up later. Step 4 is leave everything in parentheses. For last. So that 2x plus 4 has to stay there until the very end. And there's a secret here. A fraction bar is a form of parentheses. It's called the vernaculum, and vernaculums are grouping symbols. All right, so let's go ahead and finish that problem. I want you guys to pause the video, go ahead and finish doing the math for that problem, and then we'll compare our work, and then we'll move on. All right, now that you have a chance to solve that, what we're going to do first on this point is we have to get rid of that 4. So I'm going to subtract 4 from all parts. That's going to end up giving me 12 is less than or equal to 2x is less than or equal to 24. After that, I have to get rid of that 2, so I'm going to divide everything by 2. And I'm going to get that x has to be, well, I definitely can't do that in red there. 6 is less than or equal to, x is less than or equal to 12. We could write that in interval notation as 6 to 12 inclusive on both sides. So hopefully that review is helpful. We'll talk a little bit in the next video about the properties of equality and what formal terms we can use for things. So remember, if you have any questions, always feel free to email me. All right, thanks.